Welcome back to my laboratory where safety is my number one priority. And today, we're going to do an experiment on electrolysis. But first, what we need safety. There's a safety apron, the gloves, and the eyewear. What we also need is vinegar to neutralize this base that's going to happen. We're going to need graphite rods with alligator clips and 3 batteries with a total voltage of 27 volts. What we're going to do first is we're going to connect them. Simple, easy connection to secure this 27 volts. Once we connect them, we connect the alligator clips to the positive and negative sides of the battery. And then once we have that, we want to put it inside of the water, which has NaCl salt and water. So we have the anode and we have the cathode. And we put it into the water solution and we observe. Make sure you don't breathe this stuff in because chloride gas is technically toxic. So you want to make sure you stay away from this, but to observe from a decent distance. Notice how the bubbles on the anode here are bubbling up. This is where the reaction is taking place. Make sure you don't touch them together because they will short circuit and it won't work. See that the bubbles stop forming on these graphite leads. We remove them. We observe what has happened. So in this solution, we had NaCl and H2O. And that breaks together from the electricity to form NaOH as a hydroxide plus Cl2 gas plus H2 gas. And this is a basic reaction. So in order to neutralize it, we have to add this acidic compound, which is vinegar. In order to properly dispose of this liquid, what we have to do is we have to turn on the water and keep it running for a couple seconds. And then we grab the liquid and we dispose of it inside of the drain. We rinse it a couple times and we do the same thing. We'll leave the water running for a couple minutes just to make sure the liquid is properly disposed. Once we are done, our experiment is over. In order to properly explain the experiment that we did earlier, we have to go into something known as electrochemistry. What is electrochemistry? It is the study of the relationship of electricity with chemical reactions and how the electrons act in a chemical process. This movement of electrons is what causes electricity. Moreover, this powers all the electronics that we use today, such as my phone, which is what I am using to record. Another thing that we have to know is oxidation-reduction reactions. Redox reactions or oxidation-reduction reactions occur when there is a loss or gain of electrons from either side of a chemical reaction. this causes a change in the oxidation states of the compounds or the ions, where oxidation is the loss of electrons and reductions is the gain. A good way to remember this is oil rig, where oxidation is loss, OIL, and reduction is gain, RIG, oil rig. Now, we also have to talk about electrolysis. Electrolysis is when there's an electric current applied and a chemical reaction forms because of it. Bonds are broken and new compounds are formed. The substance undergoes a chemical reaction where electrons are gained and lost throughout. For example, in the diagram we have below, where we have a power source, which could be a 9-volt battery, that supplies a current throughout the solution and that breaks the bonds in the solution and creates new ones. Now, we have the experiment for the electrolysis, which is what we performed earlier in the video. The experiment that we performed was a good example of electrolysis, because there was the power source which broke the bonds inside of the solution that we had, where we got a power source and we connected it to graphite leads, and these leads were placed within a solution of the electrolyte NaCl and water. What we used were 90 grams of water, 10 grams of NaCl, 2 graphite leads, an alligator clip, 3 9-volt batteries, and the acid vinegar to neutralize the base. What we observed was, at first we observed bubbles forming on the graphite electrodes. Now, while the diagram on the right uses pencils, we used rods of graphite to properly conduct the flow of electrons. Then after 2 to 3 minutes, we started seeing that the color of the aqueous NaCl and the H2 solution started to turn slightly yellow. While we couldn't technically observe this, the bubbles that were forming around these electrodes were chlorine gas, which is technically toxic, and hydrogen gas. What was formed was NaOH, a base also known as Li, and the 2 gases mentioned above. What happened to the solution was that the electricity that was passed from the power supply, our 3 9-volt batteries, broke the bonds of the NaCl and the H2 solution. This is a good representation of electrolysis because of the fact that This is a good representation of electrolysis because of the chemical reaction that is caused by those 3 batteries. This caused Cl-, Na+, H+, and O- to become solo ions, and they bond by the Cl and the H bonds with like atoms to make Cl2 gas and H2 gas. And the sodium and the hydroxide bonds together to form sodium hydroxide, again also known as Li. When it comes to the chemical formula, we have the aqueous electrolyte, sodium chloride, plus the water, H2O, which yields through the power source a product of NaOH as a base and H2 and Cl2 gases. In order to properly balance this, we have to tell how many elements are in each side. We have 1 sodium, 1 chloride, 2 hydrogens, and 1 oxygen on the left. And on the right, we have 1 sodium, 1 oxygen, 3 hydrogen, and 2 chlorines on the right. What we could first do is we could add a 2 coefficient in front of the NaCl. That would give us 2 sodiums and 2 chlorines on the left. Now, in order to balance this, we would put a 2 coefficient in front of the NaOH base. However, this would give us 2 oxygens and 4 hydrogens on the right. In order to properly balance this, we would put a 2 coefficient in front of the H2O, which would give us 4 hydrogens and 2 oxygens on the left. And the balance equation comes out to be 2 NaCl plus 2 H2O, which yields 2 NaOH plus H2 plus Cl2.
Galvanic cells or voltaic cells supply electric current through the transfer of electrons in redox reactions. The distance between the reactants of the redox reaction is increased to produce the electric current, and it can be harnessed to do all sorts of tasks. Energy is produced from the spontaneous chemical reactions. In electrolysis, chemical reactions are induced by flowing electricity through them. The reaction in a galvanic cell is spontaneous and will happen naturally on its own, while electrolytic reactions are not spontaneous and have to be induced with an electric current. Multiple galvanic cells are used in batteries. The cells are connected in series to increase the total voltage of the battery. Cell potential is the energy potential difference between the two electrodes of a cell. For example, in the experiment that was performed earlier, we could find the cell potential between the two graphite leads that we used. When combining a compound that is likely to oxidize with a compound that is likely to reduce, cell potential increases as the reaction happens more frequently and naturally. Cell potential is influenced by temperature, pressure, solution molarity, and the compounds of the electrodes. The standard hydrogen electrode, abbreviated as the SHE, is set as a point of reference for the likelihood of a reaction to occur. This is mostly based on the compound of the electrodes. All the other standard electrode potentials are calculated in reference to it. Since so many variables can affect the cell potential, they have all been standardized at a solution of 1 molarity, 1 atmospheric pressure, and the only variable left unstandardized is the composition of the electrodes. The SHE is set at 0 volts, and anything above that is considered a spontaneous reaction, and anything below that is non-spontaneous. You get the cell potential in volts for each compound from the standard electrode potentials. The higher the potential, the more likely it is, and the lower it is, the less likely. The SHE consists of H2 gas at 1 atmospheric pressure bubbling into the solution, a 1 molar solution of hydrochloric acid, and an inert platinum electrode that is immersed into the solution. This half reaction can be represented using the equation shown.